I have f of x equals to x squared minus 2x to the third. So let's go over what I'm trying to do. I want you to find the derivative of the function using definition of derivative. If you learned calculus before, you know how to do without limit. Don't do it because I am asking you to show me the limit. That means you have to show the limit definition. State the domain of the function and the domain of its derivative. So since we are at the function right now, what is the domain of this function? So this is a third degree polynomial. The domain is all real numbers, right? So you can write interval from negative infinity to positive infinity, or you can write x is an element of all real numbers. All right, so that is how we do it. And then we need to move on to derivative. So we have f prime of x that equals to limit as x goes to 0. We have f of x plus h minus f of x divided by h. That is the formula. And then we have to plug in the function to the formulas. So we have limit as x goes to 0 always starts with limit. So we have a fraction bar. So x plus h. So for x, for the first one, for the square, you have to replace x with x plus h squared. And then minus 2 times x plus h to the third power. So this one is x plus h. Look at the function. You have to replace x with x plus h. And then minus the function. So subtract the entire function. You have to use parentheses because you are subtracting. Because without the parenthesis, you are not subtracting the 2x plus 3, right? So after you open up the parenthesis, you have to add 2x plus 3. That changes everything. And then we have divided by h. So one thing that I need to do next, and that's the reason why I bring this problem up, is because the third power. How do you open up a third power? So we have to use a technique called Pascal Triangle. If you can do it without Pascal Triangle, just follow your method. So Pascal Triangle is, we start the top with a 1, and then the second line, for each line, we always start with a 1 and then ends with a 1. So the next line, we start with a 1, 1 plus 1 is equals to 2, and then we end with a 1. And then 1, 1 plus 2, 2 plus 1, and 1. You can keep going forever. So 1, 1 plus 3, 3 plus 3, and then 3 plus 1, and then the last number is 1. And then how do we use this? The power that we are trying to expand is the third power. So we don't count the top. This is the first line. And then this is the second line. And then this is the third line. So the third line, this is the line that we will have to use. So the 1, 3, 3, 1, they are my coefficients. So 1, 3, 3, 1. Let's write down the 1, 3, 3, 1. 3, 3, 1. How do we use that? We have an x, we have an x, so we let x goes first. So here is how we do it. X to the third, x squared, x to the first, and then x to the 0, which is a 1. And then x to the third, x squared, x to the first, and then x to the 0, which is a 1. So since this is a x plus h, then we have a plus, 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 or plus. What if we have a minus? If we have a x minus h to the third, then we have x to the third minus 3x squared h plus 3x h squared, and then minus h to the third if we have a minus. So be prepared to do both. And then the rest should be easy to open up. So we have limit as h goes to 0. We have a long fraction bar. And then the first one is a x squared, right? X squared plus 2xh plus h squared, and then minus this one, you have a minus 2 times this right here. You have a minus 2 times this. So I don't want to write an extra line. I will just distribute the minus 2 to every single term and then write them out. So we have a minus 2. I can use red. So we have a minus 2 x to the third, and then minus 6x h squared minus 6. Oh, actually, this one is a x squared h. x squared h, and then minus 6xh squared. And then minus 2x to the third. And then open up the x squared and then minus 2x to the third. So this one we should go back to green. And then minus x squared and then plus 2x to the third. Remember, this is a minus. You have to distribute the minus. All right. And then you should be able to do some cancellation. Let's see. Let's use a highlighter to do it. So we are able to get rid of the x squared. What else? We are able to get rid of the 2x to the third. And then I guess that's all. So for the rest of the term, you have to pay attention to this. After all the cancellations are finished, the rest of the terms, take a look. Every single term has an h attached to it. This is required. Why? Because you need to get rid of the h in the denominator. To do so, you have to factor out an h. So we have limit as h goes to 0. So you factor out an h. We have 2x plus h minus 6x squared minus 6xh and then minus 2h squared. I don't care what's in the parenthesis. As long as you are able to get rid of the h in the denominator, you will be okay. So this one, we get rid of the h. And then now we are safe to plug in the 0. So once you plug in the 0, all the h becomes 0. So you have a 2x minus 6x squared. This is equals to f prime of x. This has a name. I am going to give you the name. This is called the slope of the tangent line. Slope of the tangent line to f at any x value. The point P, remember, I am talking about any point. This is a third degree polynomial, right? So you expect to see a curve. Sometimes the curve is increasing, sometimes the curve is decreasing. That means sometimes the slope is positive, sometimes the slope is negative, and sometimes it's 0. So the slope changes all the time. So this one has x, that means the slope is changing. So if you want to find the slope at a specific point, then you have to tell me that specific point. And now, what is the slope of this derivative? So this is a second degree polynomial, right? So f prime is a polynomial, second degree. So the domain is, there are two different ways to write a domain, either negative infinity to positive infinity, or you say x is an element of all real number. I prefer to use interval. So that is how you find the slope of the tangent line to f at x using the limit definition. So that's the first problem. Let's take a look at the next one. The next one, we have b. So b is, we have g of x equals to the square root of 9 minus x. All right. So we start with the definition, g prime of x. So this time is limit as h goes to 0. We have g of x plus h minus g of x divided by h. All right. And then you have to plug in. So limit as h goes to 0, the x plus h, you have to replace the x with 9 minus x plus h in parentheses, and then minus the function itself, 9 minus x divided by h. Oh, by the way, there is one thing that we forgot to do. That thing is the domain of g. So what is the domain of g? The domain of g is, we have a square root. So square root of 0 is okay, square root of positive is okay, but square root of negative is not okay. So the domain of g is 9 minus x must be greater than or equal to 0. All right, so you solve the inequality, negative x is greater than or equal to negative 9. Once you multiply both sides by negative 1, you have to reverse the inequality sign as well. So the domain is from negative infinity to 9, including 9. So that's how you find the domain of function g, not derivative. We don't even have the derivative right now. And then this one, once you plug in x, you have a 0 in the denominator, and you have a square root. What do you do when you see a square root? The answer is you have to think about conjugate. What is conjugate? Conjugate is the opposite sign. We talked about conjugate in the previous lessons. So you have to multiply the top and bottom by the square root of 9 minus x plus h plus the square root of 9 minus x. So that is for the top. The denominator, you just follow this because you have to make the conjugate equals to 1. Otherwise, you will change the problem. So now we are ready to multiply. So when you do the multiplication, the top, we are trying to do this. We are trying to do something like a minus b times a plus b. You are trying to FOIL this, all right? So after you FOIL, you have a squared minus b squared, okay? So go back to green. We have a limit as h goes to 0. What do we have? The top, after you multiply this radical, we don't have any more square roots, so we have 9 minus x plus h, and then minus 9 minus x, the denominator, we have h times the square root of 9 minus x plus h plus the square root of 9 minus x, and then we are ready to simplify the top. Oh, there is one thing that I missed. Do you see what I missed? Is the top correct? The top is not totally right because I missed a parenthesis. This is very important. If you don't use the parenthesis, you will mess up the plus. Okay, so let's write another line. So the top, we have h goes to 0. We have 9 minus x minus h minus 9 plus x divided by h times the bottom of the conjugate. Okay, cancellation. We have a 9 and a minus 9. We have a x and a plus x. So, and then we get rid of the h. So what do we have on top? We have a negative 1 on top, right? So plug in a 0. We have a negative 1 on top, and then the denominator, you have a 2 times the square root of 9 minus x. So what is this? This is your f prime, not f prime, g prime of x. So what is g prime of x? I forgot the prime. G prime of x is the slope of the tangent line to function g at any x value, anything, but not anything. You have to make sure the x value you plug in won't screw up the function. So what do I mean by screw up the function? Take a look. You have a radical square root of 9 minus x in the denominator. So the domain is 9 minus x must be greater than equal to 0. You might ask me, hey, for the problem you have on top, you have a 9 minus x greater than or equal to 0. Where is the equal? You cannot use an equal because once the denominator has a 0, you will mess up the function, right? So this is negative x greater than negative 9. Multiply both sides by negative. You have to reverse the direction of the inequality symbol. Yes, that's why I make this problem. So that is your domain using an interval that will be negative infinity to 9. This will be a parenthesis. You are not allowed to pick 9. If you use a square bracket, then you can pick 9. So how do we use this actually? So let's say we have a point for function g. I want you to find the tangent line at 0, 3. 0, 3 is a point on the curve. Remember, we have 9 minus x, right? When x is equals to 0, 9 minus 0 is equals to 3. So we have x equals to 0, y equals to 3. That is a point on the curve. I want you to tell me the slope. So what is the slope? When I say tell me the slope, you are looking at g prime. Once again, if I say give me a slope, you are looking at prime. You are looking at derivative. If I say give me a location of a point, I need a point on the curve, then you are looking at function g. So you have g prime of 0 that is equals to -1 divided by 2 times 9 minus 0. So that is a -1 divided by 6, right? So -1 over 6. That is the slope of the tangent line. I don't have the equation yet. That is the slope only. This one is the slope of the tangent line at this point only. I don't have a line. If you want to build a line, then you use the point slope form. In case you don't remember what it is, point slope form. That is how you build a straight line using one point and a slope. So which is y minus y1 equals to xm times x minus x1. So you have y minus 3 equals to -1 over 6 x minus 0. So overall you have y equals to 1 over 6x and then plus 3. This has a name. This is called equation of the tangent line. Okay, I'm going to write this down. Equation of the tangent line. To the square root function at this point 0, 3. See, every answer has a name. So are you ready for the next one? The next one I have a rational function for you. So that takes a lot of work to simplify. So let's do C. So part C, I have this function for you. G of t equals to 1 minus 2t divided by 3 plus t. There's a lot of algebra in this problem. So let's start with the definition. So we have g prime of t equals to the limit as h goes to 0. We have g of t plus h, not x plus h anymore, minus the function itself divided by h. So we have limit as h approaches to 0, long fraction bar. The top, we have to replace the t with t plus h. So 1 minus 2 times t plus h divided by 3 plus t plus h minus 1 minus 2t divided by 3 plus t divided by h. Okay, so I'm going to do a simple algebra right here. So let's say you have a 1/2 plus 2 over 4 divided by 5. That is the same thing as you pull the 1/5 out. 1/2 plus 2 over 4. Just an example. I'm not saying this is the answer of the derivative. So this, I want to get out of the complex fraction. So how? I'm going to pull the h out. And then you have 1 minus 2t, and then minus 2h divided by 3 plus t plus h, and then minus 1 minus 2t, save those space. We need to do something for that. What are we trying to do? We are trying to get a common denominator. So let's do the common denominator in a different color. So this one, I want a 3 plus t. So I'm going to multiply the top and bottom by that. 3 plus, not 3t, 3 plus t. And then the other side, I want a 3 plus t plus h. So 3 plus t plus h, 3 plus t plus h. And then we have to multiply them. So here is how we multiply, okay? Just like open up two factors. Again, a lot of math. If you make one little mistake, you won't be able to get rid of the h in the denominator. So let's do it. Limit as h goes to 0. We have 1 divided by h. And then denominator 3 plus t plus h times 3 plus t. The top fully open up everything. So we have 3 plus t, all right, minus 6t minus 2t squared minus 6h minus 2ht. A lot of algebra, be careful. And then minus. How do I get this minus? This minus will carry over down here. And then the denominator, don't expand that. Just put them right next to each other. And then the top, you have 3 plus t plus h minus 6t minus 2t squared plus, oh, the last one is a minus 2th minus right here. And then you have to distribute, distribute. I was trying to write dist, so distribute. Okay, next line. Limit as h goes to 0, 1 divided by h. Whoa, let's draw a long fraction bar. And then the bottom, we have 3 plus t plus h times 3 plus t. After the cancellation is finished, we can simply get rid of the h outside of the parenthesis. So first, you have, we copy this again. I don't see that we can simplify. So 3 plus t minus 6t minus 2t squared minus 6h minus 2ht, and then we have to distribute the minus, right? So let me make this more easier to read for you. I am going to use a different color for the other one. So we minus 3t, not minus 3t, minus 3, and then minus t, and then minus h, plus 6t plus 2t squared, and then we have minus 2th minus, or minus is a plus 2th. And then we do a cancellation. First, I see a 3. And then I see a t. Do this one by one, nice and slow. 2th, and then what else? T squared. And then a 6t. And then what else? That's it. You have a minus 6h minus h, so you have a negative 7h. So the next line, limit h goes to 0, 1 divided by h. The top, simple. Negative 6 minus 1 is negative 7 divided by the common denominator. Okay, let's get rid of the h. Get rid of the h, and then we plug in a 0. So once we plug in a 0, the bottom will be a 3 plus t squared. So we have a negative 7 divided by 3 plus t squared. This is equals to g prime of t, right? So g prime of t. What is this called? G prime of t. G prime of t is called the slope of the tangent line to function g at any t value, at any t. So you want the slope, then you give me a t, right? You give me a t value, I can give you the slope. You give me a t value, that means you give me a point on the curve of g. I can immediately tell you what the slope is. But before you give me a point, remember, this is a rational function. So g of t is 1 minus 2t divided by 3 plus t is a rational function. That means the denominator cannot be equal to 0. So we have to emphasize that 3 plus t is not equal to 0. So t cannot be equals to negative 3. If you take a look at the number line, we have to take away the negative 3. So this, we have to punch a hole in there. T can be anything except -3. So the domain is from -infinity to -3. So we use parentheses because we do not include the -3, and then from -3 to positive infinity. So when you give me a t value, do not give me -3, because when x is equals to -3, there is a vertical asymptote and there is no slope in there. Do not give me -3. So let's say I give you a point on the curve. I am going to let x t equals to 1, simple. How about g of 1? Just let t equals to 1. So we have 1 minus 2 times 1, 3 plus 1. I am just making up a value. So this is a -1, this is a 4. So we have a point 1, -1/4. It's a point on the curve of g. It's a point, right? I have a point. You have to tell me the slope at this point. So when you ask for slope, you have to use g prime. So what is the slope? G prime of 1 is equals to, you use the prime I just found, -7 divided by 3 plus 1 square. So that is -7 divided by 16. This is a slope. When you take something from prime, you are taking out a slope. When you take something from g, you are taking a point on the curve, a location, versus the slope of at that location. And then you use the point slope form, y minus y1 equals to slope times x minus 1. So you clean up all the math, you will get a tangent line. This is y equals to -17 divided by 16x plus 3 over 16. This is the equation of tangent line, of the tangent line at that point, 1 comma -1/4. There is a straight tangent line. The equation is right over here. The slope is -7 divided by 16. So that is part C. Let's take a look at part D. So part D, I am trying to practice your Pascal triangle. So in part D, I am going to give you a fourth power to practice. So part D, let's pick a blue. So part D, how about this? F of x is equals to x to the fourth. I want you to find f of prime for me. So what is the domain of this? The domain is, you can plug in anything, right? So the domain is from -infinity to positive infinity. Let's do it. So we have f prime of x. We start with the limit definition of derivative. F of x plus h minus f of x divided by h. And then you plug in the function f prime of x, that is equals to limit as x goes to 0. We have x plus h to the fourth minus x to the fourth divided by h. And then you recall your Pascal, right? The Pascal triangle. So we need the fourth line. We don't count the first one. And then 1, 1, 1, 1 plus 1. And then 1 plus 2, 2 plus 1. And then 1, 1 plus 3, 3 plus 3, 3 plus 1. So this is the first line. And then second, the third, and this is the fourth. We don't count the top. So we have 1, 4, 6, 4, 1. Here is how we use this. We use them as a coefficient. So 1, 4, 6, 4, 1. That is a plus, so we are doing all plus. So we have x to the fourth, x to the third, square, first, and 0. And then x to the fourth, third, square, first, and 0. So since this is a plus, and then we do all plus. And then you might ask me, hey, what if I have x minus x to the fourth? Just let me know in case. Then you have x to the fourth minus 4x3h plus 6x squared h squared. And then minus 4x1 h3 and then plus h to the fourth. So that will be plus minus plus minus plus minus. If you have a plus, then they will be all plus. But since the limit definition is always x plus h, I don't think you will need the minus. So let's bring the expansion to the top. H goes to 0. We have x to the fourth plus 4xh to the third, h, 4xh to the third. 4x to the third, and then h, and then plus 6x squared h squared, and then plus 4xh to the third plus h to the fourth minus x to the fourth, right? So this minus x to the fourth is carried down there. H, so we can simply get rid of the x to the fourth. So the rest, every single term has an h attached to it. So we can factor out an h to the third, and then plus 6x squared h plus 4xh squared plus h to the third, and then divided by h. You get rid of the h. You are now ready to plug in h equals to 0. So you end up with 4x to the third only, because all the h goes to 0. So that is equals to f prime of x. Tell me the name. This is called the slope of the tangent line to the function f at any x value, any x. Now, let's test the prime. You give me a point. So let's say x is equals to 1. What is y equal to? You have f of 1 that is equals to 1 to the fourth. So y is also equal to 1. And then what is the slope at 1, 1? At that point, you have f prime of 1 that is 4 times 1 to the third that is equals to 4. This is the slope. The 1, 1 is a location. And then to build the tangent line, you have y minus 1 equals to 4 times x minus 1. So you have y equals to 4x minus 4 plus 1. Y equals to 4x minus 3. This is a straight line. This is called a tangent line. What tangent line? This is the equation of the tangent line to the curve at point 1, 1. All right. So that will be all in this basic introduction. I will see you in the next section.